Good morning, class. I hope you are all fine. Today we are going to do set and operation on set. I know we have already learned it, but you need to revise on all that you have learned. But before that, what then is a set? You already learned that a set is a well-defined collection of objects of the same kind. So if you have objects that is of the same kind, then we can call it a set. Let's then consider the following and see some examples of set. All students in Dreamers Form 3 class is a set. Month of the year is also a set. Then colors of a rainbow is also a set. Rainbow is having so many colors. So if we list all these colors together, then they form a set. There is something we are supposed to note very well when it comes to sets. He said a set is denoted or represented by capital letters. That is a capital letter A, capital letter B, P, capital letter Q, and etc. You can use any capital letter to represent a set. So far as it's a capital letter, then it's accepted. And the member of sets are always enclosed by a curly bracket. Not a bracket, but what? A curly bracket. That's one thing you must supposed to know. If you list your members of the set or the element of a set, you must always enclose it with a curly bracket. Then also, we can say that the components or objects of sets are called the members or elements. I've already explained this, that the members of a particular set are the same as the element, or they are the object. For example, if we have A, which is 2, 4, 6, and 8, then automatically you can see that 2 is a member or an element of A. That is, 2 is an element of A. It means 2 is belonging to A. 2 is in A. So that's what is termed by an element or a member of a set. The symbol you see there is what we call an element of a set. But we can also say that 5 is not a member or element of A. You can all agree with me that there is no 5 in the set A. Therefore, 5 is not an element of A, and is also denoted by that symbol over there. The number of members or elements in a set A, 2, 4, 6, 8, is 4, and it's denoted by n of A is equals to 4. This simply means that the number of elements in that set A is 4. We can count them: 1, 2, 3, 4. So the number of elements in a set A is 4, and it's always denoted by n of A is equals to 4. I hope we are clear with this one. Now let's move on. How do we describe and write a set? We can describe and write a set by 1. Listing its members. For example, P is equals to 2, 3, 5, 7, and 11. Or R is equals to January, June, July. Or Q is equals to 1, 2, 3, 4, up to infinity. Those 3 dots you see there means up to infinity. That means there are a lot of numbers over there that we can't finish mentioning them. If we are supposed to list everything, we cannot finish listing them. So take note of that. And 2, giving a word description of its members or defining a property of the set. For example, the set P, Q, and R in I over there, or in the first one that's above, is written as, you can write the P that is over there 2, 3, 5, 7, 11 as prime numbers less than 12. Then also you can write the Q as positive integers. Positive integers starts from 1 up to infinity. Then the R you can also write as months with names beginning with letter J. If you look at the R, the months all begin with J: January, June, July. So giving a word description of its members or defining a property of a set, then a set can be defined for you and then you have to list its members. Now let's look at the third one, using a set builder notation. For example, the set P equals to 2, 3, 5, 7, 11. We can also write it as P is equals to S such that 1 is less than X less than 12, where X is a prime number. So that's how the set builder notation is. If you have been given the set builder notation, then you should know how you are going to list the elements in it. Also, the set N equals to 1, 2, 3 up to 10 can be written in the set builder notation as N equals S such that 1 less than or equals to X less than or equals to 10, where X is an integer. Take note of the N and the P over here. If you look at the P, it said S said that 1 is less than S less than 12. That means if you are listing the elements, 1 is not part of the element and 12 is not part of the element, because the condition says that 1 is less than X and X is also less than 12, so they cannot be part of the element. That's why if you check P, it started from 2 and ended at 11. But let's come back to the N. The N says that X said that 1 is less than or equals to X and X is less than or equals to 10. So that means 1 is part of X and automatically 10 too is part of X, since it's less than or equal to. Anytime you see less than or equals to, that means that number is part of the element. But if you see less than without the equal to, that means the number is not part of the element. I hope you are clear over here. Okay, let's move on. Now let's go to the types of sets. Now you all know the types of sets, so you will go through it very fast, then you move along. The first one is a finite set. And it says a finite set is a set whose element can be counted and its last number can be found. So any set in which you can count its element and the last number can be found is called a finite set. Let's look at the set example over there. Set A is equals to 1, 2, 3, 4, 5. We can all testify with me that the number of elements in set A is 5. And also the last element can be seen, which is 5. So set A is a finite set. The next one is infinite set. A set whose last element cannot be found is an infinite set. For example, the set Q equals to 1, 2, 3, 4, 5, 6. Q is an infinite set because its last element cannot be seen. Don't confuse yourself. Don't confuse yourself that its last element is 6. No. You can see some 3 dots at the end over there. It means it's up to infinity. If you are supposed to list 7, 8, 9, 10, we will go up to infinity, never ends. So that makes it an infinite set, since its last element cannot be seen and we can't determine the number of elements set Q is having. Now the third one is what we call the unit set. A unit set is a set which has only one member. So if a set is having only one number of elements or one member, then that set is called a unit set. For example, P is equals to 5. You see that P is having only one number of elements, which is 5. So P is a unit set. The same way Q equals to 2 is also a unit set. Also, A is equals to 0 is a unit set. Yes, 0 is an element. Don't forget. Don't tell me it's 0, so it's an empty set. No. 0 is a number and it's an element of a set. So A is equals to 0, 2 is a unit set. Now let's go to the fourth one, null or empty set. A set which has no element is called a null or empty set. A null set is denoted by the symbol this or that. So a circle with a diagonal through it or an empty curly bracket. That's what is termed as the null set. It's any set without any element in it. So there is no number of elements in that set. Then that set becomes a null or empty set. Now let's move on to the fifth one. That's the universal set. The universal set here is the most important of all. We'll be using it through and through as we go on. So take note of that. It is a set of all the objects under discussion. It is denoted by the symbol U or E. When we talk about the universal set here is the mother set of all the sets. Now let's move on to equal and equivalent set. Now let's see what equal set is. The two sets are said to be equal if they have the same elements or members. So if a set is having the same element or members, then they are equal sets. For example, if A is equals to 2, 3, 5 and B is equals to 5, 2, 3, then A is equals to B. You all agree with me on that? That A is equals to 2, 3, 5 and B is equals to 5, 2, 3. If you check A and you check B, you see that the elements are the same. There is 2 in A, there is 2 in B. 3 in A, 3 in B, 5 in A, 5 in B. So that makes it an equal set. Also, you can check from the example 2 that if A is equals to 1, 3, 5, 7 and B is equals to 3, n, 5, 1, then automatically if you ask to find n, you will know n, because since it's an equal set, you see that there is 1 in A, 1 in B, 3 in A, 3 in B, 5 in A, 5 in B, and there is 7 in A, but there is no 7 in B, and you are asked to find n. So automatically you must know that your n is equals to 7 since they are equal set. Now let's go to equivalent set. Equivalent set is different from equal set in some way. The two sets are said to be equivalent if they have same number of elements. Please take note. Same number of elements. In the equal set, it's a what? Same element. The elements are the same. But in equivalent set, it is saying that they have the same number of elements. For example, if A is equals to 2, 3, 5 and B is equals to 11, 12, 13, then A is said to be equivalent to B. If you check well, the elements there are not the same, but the number of elements are the same. A has how many elements? 3. And B is having how many elements? It is also having 3 number of elements. So therefore, A and B are equivalent sets, but they are not equal sets. Take note. So now note is that an equal set can be an equivalent set, but equivalent set cannot be an equal set. That's what I was talking about. Equal set can be an equivalent set. If you look at the example at the equal set over there, A is equals to 2, 3, 5, and B is equals to 5, 2, 3. They are all having how many number of elements? 3, 3. So it can also be an equivalent set. But equivalent set cannot be an equal set. Let's check the equivalent set, the example for the equivalent set. A is equals to 2, 3, 5, and B is equals to 11, 12, 13. There is 2 in A, there is no 2 in B. There is 3 in A, there is no 3 in B. There is 5 in A, there is no 5 in B. In B, there is 11, 12, 13. Those numbers are not in A. So there is no way equivalent set can be an equal set. But an equal set can be always be an equivalent set. I hope you are clear with this one too. Good. Now let's move on. Let's move on to subset and number of subsets. First, let's take subset. If, for example, I've given you a set A, 2, 4, 6, and set B, 2, 4, 6, 8, 10, 12, then I can automatically say that A is a subset of B, or B is a subset of A, with the subset symbol 10. Be mindful of that. Why am I saying this? Because A is a subset of B. If we check the elements in A, they are all in B. Is that not true? Yeah. All the elements in A can be found in B. So that's why we say A is a subset of B. But somebody too can say the elements in B2 are in A. But be mindful, the word there is all the elements in B in A? No. The only elements in B that can be found in A is 2, 4, 6. There is 8, there is 10, there is 12, and it's not found in A. So you can't say B is a subset of A, but rather you say what? A is a subset of B, since all the elements in A are found in B. Are we clear? But if you want to bring the B first, B subset A, then that means you need to turn the sign for the subset. That one is accepted. But please, let's all stick to the first one so that you don't get confused. Okay. Now you try your hands on this one, and then I'll be taking the answers after you are done watching this. Let's move on to number of subsets. With the number of subsets, let's take this example. Say a set C equals to 0, 1. Then we can say that C is having 4 number of subsets. 4 number of subsets because we want to generate subsets from C. And generating subsets from C, we can see that we can get a set of 0, a set of 1, a set of 0 and 1, and then an empty set too from this set. And at the end of the day, we are going to get 4 subsets from the set C, which is equals to 0, 1. I told you subset means the set 0 is in set C, the set 1 is in set C, the set 0, 1 is in set C, which is also 0, 1, and there is empty set in that set C also. So in general, we say if a set has n elements, then the number of subsets the set has is equals to 2 exponent n. So for example, if my set is having 4 elements, then the number of subsets I must get is supposed to be 2 exponent 4, and 2 exponent 4 will give you what? 16. So that means I'll get 16 number of subset. I hope you are through with it. Now let's take this example. A is equals to ABC, and we want to know the number of subsets in A and also list them. So we know that A is having how many elements? Number of elements 3. So going by our formula 2 exponent n, then it's going to be 2 exponent the number of elements, which is 3, and 2 exponent 3 will give us what? 8. So we have 8 subset. So we are supposed to list all these 8 subset. When it comes to listing the subset, you take a set of 1s, a set of 2s, up to a set of number the set contains 3. Here our set contains 3 number of elements. So a set of 1s will be set A, set B, set C. Then a set of 2s, that will be set AB, set AC, set BC. Then you go to a set of 3s, then that will be a set of ABC. And always we must know that an empty set is part of the subset of every set. So if that's the case, then you try your hands on this. How many number of subsets has the set P? 1, 4, 6. State them. I'll be checking your answers later. Make sure you do it. You take this one as your reading assignment. Make sure you read. The first one is set of numbers, and the next one is listing the elements of a set. You can refer to your textbook and then you read more about that. If you have any problem, you send me a message and I'll help you out. Thank you. Now let's move on to intersection and union of sets. So we will take the intersection of sets first. The set of objects which belongs to A and at the same time B is called the intersection of set A and B. That is A intersection B. The symbol there means the intersection. So you have a set A and you have set B, and you realize that the elements in set A, some of the elements in set A are also in set B. Those elements are called the intersection of the set A and B. The diagram here will explain better to you. So we have our universal set over there, and then our set A and our set B. You see, where they meet becomes the intersection over there. The shaded part, the one shaded in red, becomes our intersection. So when we get to two set problem, I don't think you have difficulty in showing me intersection. Now let's see the diagram too. We have the universal set, then we have our set A, then we have our set B. Looking at this one, we can see that the set B is inside the set A. So if you want to find the intersection over here, the intersection will be the whole of the set B. So the whole of the set B will become the intersection. If it happens that way, that means all the elements of B are intersection, and some part of the element of A is also part of the intersection, but not all the elements of A. I hope you get this one correct. Okay, let's move on. Let's take this example. Example 1. P is equals to 3, 6, 9, and Q is equals to 1, 3, 5, 7, 9. Looking at this two sets, P and Q, there are some elements in P which are also in Q. Can you mention them? These are 3 and 9. So 3 and 9 becomes the intersection. That's why you have P intersection Q is equal to 3, 9. Don't forget to put it in curly bracket. Good. Now try your hands on this one, and then I'll be taking the answers later after the class. Let's then move on to the union of sets. The set of objects which belongs to either set A or set B or both is called union of A and B. So if I have a set A and a set B, then all the elements in set A and all the elements in set B together becomes my union. Whether there is intersection or not, it still becomes my union. And the symbol there, A union B, use that symbol to represent the union. Now let's look at this diagram and see how the union looks like. So my universal set is there, then I have my set A and I have my set B. Then if I ask to find A union B, that means all the elements in A and all the elements in B. So all A and B shaded together will be our union. Now let's look at the next diagram over here. Given the universal set, rectangle over here, then we have a set A and we have set B. The whole of A and B will become our union. So union always is like addition, A and B. All the elements, just write them together. But be mindful, if the elements appear twice, you write only one. Please, only one, not all the two. Okay, let's look at this example. Example 1. If P is equals to 3, 6, 9, and Q is equals to 1, 3, 5, 7, 9, then P union Q will be what? Then you know that we said the union is all the elements in P and all the elements in Q. So putting all the elements in P and Q together, we have 1, 3. You see there is 3 in P and there is 3 in Q. So I don't expect you to write all the 2. You write only one of the 3. Then 5, 6, 7, and then you see 9 too is appearing too. So you write only one, which is 9. Make sure you always arrange them in ascending order. Don't be messing them up, please. If that's so, then you try this one too, and then you get me the answer. Now let's move on to the last aspect of today's class. That's complement of a set. If A is a subset of a universal set U, or the symbol over there also representing the universal set, then the complement of A is a set of elements which belongs to the universal set U but do not belong to A. The complement A is written as A complement. That symbol over there makes it the complement. If you write it without that symbol, then it's not a complement. When we talk about complement set, it simply means that if, for instance, I have one universal set, say U, and I have another set A, all the elements in the universal set that cannot be found in my set A becomes the complement of set A. I hope you get that one. I have my set A and I have a universal set. Now, there are some elements in the universal set, but they are not in set A. Those elements become the complement of set A. Let's take example and then you understand. But before that, let's look at this diagram. We have the universal set over here. Then we have a set A in it. Always, I've told you that a set is a subset of the universal set. So they are always inside the universal set. The universal set becomes the mother set here. So the elements of set A are the one in red. Now, apart from that, the one all the space outside set A in the rectangle, the one I've shaded with red lines, becomes A complement. I hope you understand this one. Let's take example and you understand very much. Example 1. If U is equals to 2, 4, 6, 8 and Q is equals to 4, 6, then Q complement is equals to. Now, let's look at U. U is equals to what? 2, 4, 6, 8 and Q is equals to what? 4, 6. You see, U becomes our universal set here. Looking at the universal set, let's compare it to the set Q. We are looking for all elements in U that are not in Q. So what are some of the elements in U that you cannot find in Q? That's what is 2 and 8. So that one becomes your Q complement. I hope you understand this one. If yes, then try this one for me. If U is equals to 1, 2, 3, 4 up to 10 and P is equals to 1, 3, 5, 7, find P complement. I'll be taking the answer for this one too. This is a trial 4, so I'll be taking the answers for 4 trial questions. This brings us to the end of today's class. Thank you and stay safe. Bye.